Okay, here we go. There you go.
That was perfect. Okay, cool. I can see chat now too, so now I can answer questions in chat. Okay, all right. So that's kind of the information overload at the start of things. Now we get to go do a whole bunch more interactive stuff, right? So we're doing this. Please raise your hand, say things. It doesn't matter if it's right or wrong. Most of this stuff, there's no real right answer anyways, so there's always trade-offs. I'm not going to roast anyone. If I know you, I might roast you. No, I'm joking. I'll just roast Eric. And so first question here. To what extent does a programming language affect software design? Right? So with what we've learned about software design, how all these different trade-offs go, how does the programming language affect this? Yeah. Not much. Okay. Yeah. So why would you say not much?
The only thing I can see as like an actual problem is depending on the level of programming.
There you go. Okay, someone else. When he said level of programming language, someone else interpret that. You want to go?
Yeah, I think it finds dynamics to like architecture. It's kind of like materials. If you're building bridge out of bricks, that's probably a good idea. Whereas if you're building a bridge out of very
I love these terrible bridge analogies. These are great. Yeah.
So as far as like software design goes, I think you should have a very good idea of what it is you want to do before you pick a programming language. Obviously, if you're going to build like bank software, you're not going to choose to do that in assembly or in MATLAB. So like
you might slightly be wrong on that. Most bank software is actually built in Fortran, which is an old language that's literally 58. So
but I mean, but you want to pick what you're doing.
No, maybe that's algo. Maybe it's Fortran 60, 64. There's different versions. Anyways. Yeah. Okay, so the answer is not a lot and very a lot. So the short summary is that what happens here is that not all programming languages are the same, right? So think C versus C++, right? C is this low-level language that just kind of has a lot of very simple procedural basics. C++ gets a lot more complex because it adds in things like classes. It adds in things like inheritance. It adds in things like templates, right? It adds in these higher level features that you don't see in C, no pun intended. And so the end result is that the way you would design software in C literally cannot be the same way you would design it in C++. But if you were looking at, say, C++ and Java, which are both object-oriented languages that are very similar and have a very similar number of feature sets, then the way you would design software in those are going to be significantly closer. And likewise, at the more extreme level, you could have a functional programming language like Haskell, and good luck trying to get anything not Haskell to look like Haskell. It just won't work. Okay. Cool. All right. So let's take a look at. So design by contract. So design by contract is a view of software that treats these types of systems as having a contract where the two parties in the contract are the client. So this is the person using some type of function or whatever it is we're talking about. Generally, we talk about this as a function for examples, but also kind of a system as a whole, right? All these classes and everything. And then your supplier, which is the implementation, right? So once again, we kind of have this API implementation split. Okay, so the job of the client is to meet all preconditions, right? So in other words, if I want to use code someone else has written, then I have to meet those requirements, right? So the example that we'll see here on the next slide is talking about a square root function. And so in other words, prerequisite 1 of a square root function. If I give it the string cat, it will not like that. I cannot take the square root of the string cat. It just doesn't make sense. And it won't, it doesn't have to make sense, but it just won't work anyways. And so the job of the client is to say, give it an integer value, or maybe give it a decimal number, right? Whatever it wants. The job of the supplier is to meet whatever post conditions there are, right? So if you give me a number that I can take the square root of, I will give you back the square root, right? And so, of course, if the client doesn't kind of hold their end of the bargain with things, and they do some mistake, for this one, it's pretty easy, right? If it's a number or not a number, you can check that pretty easily in most statically typed languages. But if you think Python, for instance, right, or JavaScript, a lot of the times you might have to check if the arguments are the correct type or not, right? And so if they're not the correct type, then you can basically error and say, well, you gave me the wrong stuff, so I don't have to, do all of this other things that the function would normally do. So that's basically the formalization of that. And so both sides assume that the other is doing what they should do, and then they can verify as needed, right? And so there are some reasons why you do want to verify just to kind of make sure that everything's good. There are other reasons why you don't, for example, performance. So yeah. Okay, so here's the square root thing that we talked about, right? So we have this public int square root, int number, right? So this is some Java-esque type of pseudocode. I think it's like legit Java, but I won't promise it. I try to be pretty close with the examples because, every time you're in class and they're like, okay, this is like pseudocode of a language that will probably be working within the class for the entire class, but, no bets that it actually compiles. It just confuses the hell out of everyone. Anyways, so here we have the square root function, right? And so, right, what are the difference between these, right? So what are the contracts for both of these? Right, go ahead. Yeah, so the implementation does and returns the appropriate thing. Right. So add stuff. Let's see. So other questions here. Let's stick with the integer one for now, right? What happens if it gets a negative number? It's fine. Okay, so square root of a negative number, we're returning an integer value, not something that's a complex number. So probably not fine. So what could we do here, right? So yeah.
You could say if number is less than 0, return -1.
Okay.
The user would have to know that -1 means we can't do that.
Right. We could do something like that. So that's called a sentinel value, right? So we return a value along with the result. That's some special number. -1 is common in most C applications and C style libraries. Yeah. We could throw an exception. I prefer the exception approach in general, because if you're trying to take the square root of a negative number, probably you've messed something up by that point already anyways. So there are other options too with things. So there are some languages that do something really weird, which is that if the number is negative, it gives you the negative root, right? Because every number has two roots, a positive and a negative root. And so it gives you back the negative root. And so that's kind of like the define errors out of existence type of thing, right? So this function is it takes an integer number and it will return something for every single one of those, right? Whether that's the best approach or not, maybe not, because if you accidentally get it into a negative number, then you just get a negative number back and it just, proliferates this error down the road. What about the return value, right? There's something very interesting that happens here, right? Our second one is a double, right? But this first one is an int. How does that impact things? Yeah, go ahead. Okay, so should is an interesting question, right? So should means a bunch of different things. So the short answer is, without knowing how this code is being used, we don't really have a way to answer should, right? So for instance, returning an integer might be perfectly fine if we're just trying to estimate the value, right? We're doing simple approximations, other things like that. It also might be fine if we're not doing anything that requires a super precise answer. So there are many cases where like the right answer is a double, but getting an integer back is perfectly fine here. But we don't know how it rounds, right? So how it rounds is an important thing too. That's part of the contract, right? So if I ask it for the square root of 3, what do I get, right? If it rounds down, right? If it floors, which is what most integer stuff tends to do, then I get 1 back. But if it actually rounds, then I might get 2 back. Side note, there are different rounding modes in different programming languages, so you will get different results on various things. For example, Python rounds half even. So 1.5 rounds to 2 and 2.5 rounds to 2. Google that if you're interested, because that's a crazy one. Yeah. Cool. Alrighty. So else to try. So we have this account class, right? Private dollar balance. First thing, what's the most immediate thing that you can think about on a contract for this? So what is it? Just a personal account, right? Okay, so if I have some amount of money, what is true about that amount of money? That is a good point. So you're jumping the gun there, but that's a huge thing, right? Never store money as a double because doubles are just inherently imprecise. What would you use instead? Do you know? How would you use an int?
Maybe like, you always count the like last 2 digits.
That's a good option. May not necessarily work for every currency though. So you do have to be careful with that. But yeah, int is the standard way. There's also things like big integers or big decimals, which are precise for that regard. So float's probably going to be less precise. Okay, so what else is true about our balance? Right. So think if I have a balance in an account, what's probably true about that balance? Yeah. So I hope not. Not my account, at least. You may be a different story. So hopefully it's the other way around, right? It's at least not negative, right? It may be 0, feels bad, but it's hopefully going to be some non-negative number, right? So our contract might be like, hey, the balance must always be positive, right? Or strictly speaking, it must be non-negative, right? Because positive is not 0, non-negative is also 0. Okay, so now we have something like this, deposit, right? So we carry this through, right? So we have some deposit function. So what happens here, right? So we'll think, yeah, right, let's think. So we're dealing with these positive, negative cases. So how does that affect things here? Yeah.
Well, if you have unless you have a withdrawal method, then with depositing with a negative double the amount.
It definitely could. In general, that is probably a better way to hand things at some lower level. For the simple reason of eventually it's just going to be some like atomic transaction. And so that transaction is just going to be a change, right? So that's a good way to handle it at low level. Depending on how you want to design things, you could decide, hey, I'm going to also do that for what the user does, or I'm going to have 2 separate deposit and withdrawal methods. If I do have 2 separate deposit and withdrawal methods, then I probably want to be careful to make sure that they're using the correct one. So that's the other thing going on there. So yeah. Okay.
Yeah, you should make sure that it doesn't use any NAND or infinities.
Oh my gosh, yes. There we go. Okay, so this is the other thing too. Double values have a variety of things. So in addition to, so not just having positive and negative infinity, there's also a NaN, right? Not a number, which is like what you get if you divide by like 0 by 0 and other stuff like that. And so NaN is not equal to itself. So in other words, x equals y does not actually mean that x equals y or not, because NaN gets thrown in here and messes everything up, because NaN is not equal to NaN. And so that's actually kind of a huge problem for a lot of database stuff. It's also a common problem with sorting, right? If you're sorting double values and NaN gets in there, then you can get inconsistent sort results. That can be particularly problematic for some naive sort algorithms because they depend on things actually happening. And so in other words, if the comparisons don't make sense because NaN is not giving an accurate result, it's basically just always saying that it's not equal or it's always less than other things, then it'll just keep indefinitely shifting things around and you'll get infinite loops. So think about that for a second, because it's kind of wild. But yeah, so that's a good point too. Okay, so and now it's time for whatever this is. Okay, find the error. So we have some main function in Java, right? We have a list of strings, and this is just a list of 1, 2, 3, right? So arrays.asList is just a helper function that I use to write all of these on one line. There's other ways to do this, but this is nice. Actually, later version of Java is a better way, but I have been using later version of Java too much. And then here what we do is we print a get last element of whatever this list is. Okay, so this get last element function looks like this. So I'm going to pause for about 20 seconds. I need to read over this. So first off, get last element is supposed to return the last element of the list, right? So it's not trying to do like, oh, it's named differently than what it's supposed to do. It's not trying to do anything like that. There is an error here, but it's not totally clear what it might be. Right? Someone else, because you got the NaN one, and that's huge. So anyone else? All right, I'll let you have it. So, oh, yeah. So Java, no, we just have generics. So if you're thinking like template, like C++, that would be different. So yeah, the syntax here is fine. It's the code logic that we're focusing on. So think you had something? So yeah.
I think the error is get last element doesn't take account if it's empty.
Right, right. So what happens if the list is empty, right? List.size returns what? 0. 0 minus 1 is -1. And what happens when you do list.get -1? Get an index out of bounds exception, right? Okay, so now what? Well, we can do this, right? So Java has this handy thing called assert statements. This is literally just your preconditions, right? So you can assert that this precondition is true, standard design by contract stuff. And so we assert that the list is not empty. And if it is, then we throw some type of assertion error that says the list cannot be empty. Okay. So, okay. So we did this, but we still have this error, right? So the error says java.lang array index out of bounds exception -1. And it's coming from some array list element data method and then array list get coming from our get last element method in main. Okay. So first thing I'm going to say is that the assert statement is fine, right? So there's nothing like weird languagey things that are different about assert statements. For example, it's not like assertions were disabled when I ran this or anything like that. The assert thing is working fine. So question, what could possibly cause this? Yeah. No, assert's fine. So assert here. Right? Yeah.
This is a well guess, but like sometimes this has capacity, and instead of size, we refer to capacity. But I mean, I'm already sure when I still think this is.
You're getting closer to the right track, right? You're getting very close to the right track. Okay, so the assumption about this assert statement, right? For this assert statement to make sense, what has to be true? Yeah. So no, it's not about that. Data type is fine, right? You had an idea? That's much closer. So it's something to do with list.empty and whether that's actually checking what we want it to check. Right? What is the assumption that list.isEmpty is checking? Okay, the list definitely is existing, right? Yes, right? So list.isEmpty is supposed to be checking if the list has 0 elements or not. So what happens if list.isEmpty returns something completely different from whether list.size is 0 or not? We get something like this, right? Okay, this is what it looks like. This is perfectly valid code. You can do this in Java. You can pull this up on anything and compile this and run this, and you will get the same error message, right? What this does is it overrides the size method to simply say the size is always 0, right? Okay. This is really, really weird for a lot of reasons. One, this probably shouldn't even be possible to begin with. But two, the other thing that's annoying, and I'll jump back here, we don't even see this class anywhere in the stack trace. Right? What do we see? We see the standard Java ArrayList class. Right? We don't see this MyList class that exists. Right? We would have no idea that MyList class is even involved here. Right? So think about what this could happen if you're passing these lists around all over the place. You have no idea what type of list you might be working with. Right? So if this is something rare, like 1 in 1,000, right? Rare in computer science is probably closer to like 1 in 100,000 type of thing. You might not be able to replicate that with any degree of accuracy. Okay, so question, what's the point? Yeah. Don't go overriding important stuff. Yes, definitely don't do that. Unless you're building PowerPoints based on stupid hypotheses, then go for it. More important point than that, though. Yeah.
Don't always trust the methods that you're using, but
Yeah, that's a good conclusion. Yeah.
Defining the results that, like, you're intended to think.
Making it clear what the behavior thing is supposed to be. Right? Yep. So that's fair. In this case, right, the issue is not in the client, right? It's in the implementation, right? So the supplier here is broken here too, right? Okay, so the point of things is things don't always do what you expect in general. Sometimes verifying it is ineffective. The other thing is that, in those type of situations where you don't know the degree of trust going on, you have to be very, very, very careful. This is also a huge case for trying to basically track error messages as good as possible. For instance, a sophisticated language would ideally take this list, right? And it would say this list object is part of this assertion. And this error message is going to include everything that I know about this list. It's going to include its type. It's going to include stuff about its data, stuff about the data that's relevant to this, kinds of other things. Like that. The other thing is that you have to keep in mind this design by contract thing, right? So this is inheritance. A better way really is that ArrayList, having certain methods be overridable is probably not a super good idea. It really depends on the situation, but you have to be very careful with how this is handled. And then the implementation things, what you have is this option for the contract to be broken. Right. So you have one thing saying one thing, but then it's doing a different way to check this with the other. And so that's how you get weird things like this. Okay. Whoa. I'm going to skip too far ahead there. All right. This is kind of this thing. This is the last main concept we'll talk about. And so I'm going to talk about 3 kind of key pillar ideas, right? So one is correctness, right? So does the code actually do what it's supposed to do, right? Another is performance. Right? Is the code fast enough? Right? And so fast enough is kind of weird wording. But one thing to keep in mind with fast enough is that it's, performance, like some people are like super crazy about performance, right? Like everything has to be in C++, right? If you even write something in Java, right? Heaven forbid, right? And if you do it in Python, I will kick you out of the room, right? Being that crazy about performance, probably not a good idea. However, performance does have some major impacts, right? So one, latency is huge, right? If it was Amazon, it was basically like for every 100 milliseconds of latency, we're losing millions of dollars, right? The page loads are very, very important. The other thing is that you might be dealing with server costs too, right? Especially when you're dealing with things where things scale, right? If you're not performant enough where you have to start splitting things off into multiple servers, now you have additional work with linking all of those together and making sure that the results are accurate. So performance can be very important. And then last thing is maintainability, right? We've talked about maintainability before, right? How easy is it to basically change and adapt to things over time? If the software is not maintainable, it's not going to do a good job managing that. And so like fixing bugs and other things like that is going to become virtually impossible. Okay, question, what's the priority? Okay, so if you're in Zoom, we can get ready here. I'll keep an eye on Zoom for this one. I tend to not do a good job of that. So if you're in Zoom, there's like a raise hand feature or something like that. I hope that we have access to that right now. Otherwise, this will be a train wreck. Okay, so if you find where the raise hand feature is, just be ready to use it here. Okay, so what's the priority of these? So I've done a little bit of explaining about this. You've all probably kind of seen the question on the screen and have probably thought about it a bit. So who thinks that the most important one of these three is correctness? Right? About half of in person. Zoom, we're seeing raise hands. So seeing 4. Seeing a tada too. Thanks, Isaac. A chunk. All right, who thinks the most important is performance? Okay, maybe someone on Zoom, or that's just a delay, hard to tell. Performance is probably not the most important one. Okay. And then who thinks the most important one is maintainability? Right. Okay. Why maintainability? So it's maintainable, but what like if the software doesn't work, then who cares how maintainable it is? So
if it's maintainable, then it should be easy to like make it correct and perform it. But if it's correct and it's like an unmaintainable pile of crap, then like you won't be able to like expand upon it really.
So thanks. It's almost like you read that out of like the Robots manifesto.
I didn't read it. I didn't know there was one.
Okay, yeah. So right. So this is what I would say the priority is. And the reason is because when you track through, right, every one of the things on top supersedes the ones below, right? So for example, your baseline is like if you don't have something that is performant, but it's correct and maintainable, then you can work to make it performant, right? If it's not correct, then you need to start there, right? So if it's maintainable but not correct, then you can work on it to make it correct. If it's not maintainable but it is correct, then it's like, okay, we have a good, that works fine for now. The problem is software consistently changes and evolves, right? We're always getting these new features, or we have this new idea that we want to try or whatever else, right? Our business is like, hey, our competitor did this thing. We need to like get this thing going. We need to have this launched in 2 weeks for our customers. Otherwise, we're going to fall behind, right? Like that's a standard story that, you can have come out of industry, right? And so the result of that is that maintainability supersedes correctness. And the reason why is because correctness is only dependent on some specification of what the software should do. And if that specification changes, then whether it's correct or not changes. And so the end result is that you need to kind of prioritize maintainability. Right now, what this means is it doesn't mean, hey, everything that's not maintainable or could slightly impact maintainability, right? We need to throw that out, right? There's a balance, right? This is kind of an all else being equal. This is roughly how you should be trying to prioritize things. That make sense? So, because laws in software stuff tend to not, laws in most things other than like physics tend to not, even physics stuff, like the laws are there. We just have no idea why they work. But most software stuff, it's basically like more like rules, guidelines, things that are generally true, except in like the 12 cases where they aren't. But this one I think is a pretty good baseline to kind of measure things off of. Okay, cool. So last but not least, we're going to talk about some next steps here. And so this is just kind of a variety of different advice that I'm kind of throwing out there for, okay, so I've seen this, there's a presentation, great. Now what the hell do I do? Okay. First things first, please. What is happening? Why are there no slides? Did it just, what? Nothing's moving anymore. Okay. I wonder if there's a really bad animation on this somehow.
Oh yeah, like animations on Google Slides.
What is this?
Sometimes crash my computer.
There's like, can sometimes crash. Okay, we're not going to deal with animation, so deal with the slight wall of text. Number one, go develop some software, right? How many people have worked on a project outside of a class project? Okay, great. How many people have, quote, finished that project or one of those projects? Okay, even better. That's actually like most. So I'm honestly impressed. That's beautiful. And so the reason I say why is, first off, pick an approachable project, right? So figure out where's my skill set, right? The goal is to learn something, not go build like a freaking company right now, right? Because one is approachable, the other isn't. Trust me, I've tried. That you have an interest in, right? If you don't have an interest in, you're probably not going to make too much progress with it, right? Having interest in that is what's going to keep you working on that project and kind of see it through to the end. And the reason why I have see it through kind of highlighted and italic here is that this is by far the most important, because in general, you're going to tackle the easiest things first. So you're going to get like 80, 90% through the thing, and you'll basically have done stuff that you've already done before, right? You know, so there's a law of software engineering that's basically like, you know, the first 80% of the project takes 80% of the time, and then the next 20% takes the other 80% of the time, right? And that's really true, right? All of that learning experience comes right at the end, because right at the end is where you're putting the finishing touches on everything, and that's where the cracks start to show, right? That's where your software design is going to break apart. Right. And so there's a good example of this, and, you know, I'll worm it in here. Years ago, like the main healthcare.gov app that was created, right? This is like a multi-million-dollar software project. This thing was like huge, right? So there were teams of like hundreds of developers working on this thing. They built it with the waterfall software method, right? And then like these teams were isolated, and then they tried to like combine it all together. And when they tried to combine it all together, shockingly, it didn't work, right? So basically when this thing released, right, you know, so many people were trying to sign up on the site, right? Everything just broke down, right? So like, we're talking like hundreds of thousands of people probably trying to sign up on this thing, right? How many succeeded? Like 6, right? That's how many people succeeded, and this thing just went like completely down, right? So I think what actually happened is they got another group to like build it that had like a team of like 5 or 10 developers, right? They brought people in like who had built like startups and other stuff like that, and basically said just like get stuff working. And they got it done for like way cheaper and way faster with a team of like 10 people, right? And a huge part of that is because the degree of complexity and everything. Part of it is also feature creep too, right? When you have this thing, right, you need to narrow down exactly what you want to be focusing on. Anyways, long story short, pulling everything together at the end is where nearly all of that learning experience comes from. So make sure that you're doing that in your projects. Otherwise, you know, you're somewhat wasting time, right? Because you didn't finish the project, and you didn't learn anything in the process either. So like at least do one of the two. So next, learn software design patterns, right? These are those kind of reusable components I mentioned. There's a good resource called the Gang of 4. Right? It, you know, sounds like this weird cult. It's a book by 4 authors. That's how it got named, the Gang of 4 Design Patterns book. It's kind of like the standard de facto text and design patterns. It came out in like the 70s, maybe 80s. And so this identifies, I think, 23 design patterns. Some of the favorites are factory, builder, visitor. Singleton was on an earlier slide too. These things you see everywhere, right? You have probably used either directly or indirectly every single one of those. Right? You probably just might not know it, right? Okay. And then finally, learn a variety of languages and frameworks, right? The key thing here is variety, right? So for example, object-oriented versus functional languages. If you've learned C++ and then Java, that could either be yes or not much, right? If you've learned C++, but you've never actually done memory management, that's kind of a problem, right? Has anyone here used Malloc? Okay, so that's progress, because I've never used Malloc, right? And I went through programming 2 here. It was a garbage class when it happened. It's gotten better now. So meaning is that Malloc is one of 3 ways that you can allocate memory in C++, right? Very few people have actually like done that type of memory stuff out of the people that I've talked to, right? So if you don't have experience with that low-level memory management stuff and working with all those things in C++, then basically you've just learned Java, but C++ syntax, right? Likewise, there are a whole bunch of cool features about Java that you've probably never used, you know, so do that type of stuff too. But there's also other types of languages and other paradigms. So functional languages are a huge thing, right? I give a +1 to Elixir here, partly because that was like kind of my first functional language that like I actually did some major stuff with. I had a blast with it. I took a lot of inspiration from Elixir with building my language too. There's a lot of cool things that come out of functional language like pattern matching, right? So other things are Lambdas. Pretty much every major language has gotten Lambdas now, right? C++ has Lambdas in the newer versions. So as of like C++ 14, I don't know if that's right or not, but anyways, at least modern C++ has Lambda expressions in it. Java has had Lambda since Lambda 8, since Java 8, right? And that just kind of keeps going and going and going. And there's other things like pattern matching. So Java is getting pattern matching, right? So that's a thing. And then Rust, which is another kind of C++S type of language. Rust takes so much more inspiration from functional languages that it's just very similar in that regard. But if you've never used a functional language, you won't know how to identify those types of pieces. Anyways, that's enough fanboying over functional languages. Web frameworks, right? So Angular, React, Vue are kind of the main three. There's also a couple of other like crazy ones. Ember is a thing. There's other front ends that you can use like, Flutter and other stuff. Svelte, yes, I do love my Svelte, except not anymore. Svelte is still cool. It's just heavily in development. Anyways, I think it's a good idea if you're interested in that type of web development stuff, try to use at least 2 of these frameworks and get some experience with it, right? Ideally, you probably want to go for a couple more simply because there's so many of them out there, right? That it's worth just saying, hey, I'm going to build like this little hobby site or whatever is kind of like a weekend hackathon project just in this framework that I've never used before with the intent of probably never using that framework again. And the reason why is this last bullet point, which is you want to ask, why are all these things different, right? And when does the difference matter, right? Because most of the time there's things you can learn from one of these that you can pull back to the other. It will help you understand the underlying pieces. And understanding those underlying pieces is kind of one of the key things that is missing from software engineering today, as well as a lot of education and other stuff like that, right? Like if you don't understand, right, how React works, right, and in particular things like the virtual DOM, right, then you probably need to at least know a little bit about the virtual DOM before doing anything serious in React, right? So like pull up YouTube, search virtual DOM, watch like an 8-minute overview by, some sketchy person or something, and then kind of go back to your React stuff and you'll have a little bit better understanding of what's going on there, right? Okay, I'm going to call it there and I will pass things back over to Eric. So back to your regularly scheduled SSD. So, oh yeah, do we have any other questions? Things like that? Questions? Yeah.
Well, it's not a question. I have to go, but
It's not a question.
because this is our first meeting, I want to go through photos. Is everyone comfortable giving me a photo? Everyone like, I want to do a photo.
All right, I'll steal your seat. I could use mine, but I feel like I'll be slightly out of photo range. Does anyone have any other questions while we take pictures? Yeah. Oh yeah, virtual DOM. Basically, so React does these auto updates, right? That's the key thing of React, it's reactive. And the way that piece has to work is that if you're updating the actual document object model that is like HTML type of structure, that's expensive. It's very expensive. Did you already take the picture?
No.
Oh, okay. I was like, I didn't even smile. Right?
I just left my battery at home, so I'm just using my phone.
And so React manages its virtual DOM, which is basically a copy of the website that it can work with and modify. So that's why I'm suggesting to understand it.
Oh, okay.
We need to get zoom in the photo.
I guess I'll just kind of sit down.
All right, go back. Seat. Eric, go nuts.
Just have like a couple more slides where I want to talk about what's upcoming for this next semester. So we have once again a meeting planned every week. So we have a lot of things We're gonna have a workshop on natural language processing. We'll touch a bit on, machine learning, more details on that later. We'll have a workshop on test-driven development. Test-driven development is something that's very valuable if you're looking for an internship. Companies do want students who know how to test and not just how to code. We'll try to put something together with cybersecurity. We might have something on mobile development if we have time, but we'll also have something on software engineering. We'll have social events. We'll have, an event with our Minecraft server. We have a Minecraft server, by the way. And we also have something called hackathons. So hackathons is basically just a minor social event we have on Saturdays. Basically what happens is we rent a room in the Marston Library basement sometime around noon, and people go, and it's really just, just chill and talk. Just, I always try to work on personal projects, but I always end up getting distracted. We do have one this Saturday. It will be in, I believe, room car in Marston basement this Saturday afternoon. Just totally chill. Just come if you want, right? Nothing serious. And what to expect from the first few meetings. So next week, same day and time, Tuesday at 6:15, we will have Git, but we'll be doing things a bit differently this semester. So we always like to do Git at the start of the semester because we have a lot of new people, but a lot of people who might already know Git, and so we'll be holding 2 simultaneous workshops. We'll have a basic workshop given by me. If you don't know anything about Git, then the beginner one is for you. Blake will be giving the advanced one. If you already
First
know,
time hearing about it. Okay.
What? I thought that was what we did, though.
Yeah, you did volunteer yourself on
Yeah,
Friday.
well, we'll
Volunteer, but not.
Okay, I'm sorry. Okay, so if you already know the basic Git commands, add, push, pull, commit, then and you're probably comfortable with merging, then the advanced one is for you, right?
Actually, can we have people hands? How many people like use Git for a product before and are pretty comfortable? Right. Okay. So y'all would be interested in so advanced stuff would probably do things like Git rebase, right? So more on branching and other stuff like that, and some of the other things with Git history. So that'd be something y'all are interested in, as opposed to acumen push again. Okay, cool.
Brian asked, what are some examples of things we'll learn during these meetings? So these meetings are still being planned. Let's see, mobile development. We'll just go through the process of how to create an app. What are the different types of apps? We'll touch upon a couple different frameworks. Android versus iOS. Cybersecurity. We're still planning that. More details yet, but test-driven development. We'll touch upon continuous integration, continuous development. We'll go through a workshop with JUnit, which is a framework for Java. Right? It'll be good.
Quick question with
Yeah.
test-driven development. Are we going to be using some kind of are we going to be doing test-driven development just in an architectural sense, we'll be creating it, or are we going to be leveraging some kind of framework like G-test?
For the workshop, I haven't fully planned the workshop, but basically I was thinking we have some very simple Java project, something anyone could make, nothing too complicated, and then we just write some the deal with test-driven development is you write tests first. And so you have an idea of what you want to make, you write tests first, and then you write the code. So we'll be using JUnit. We'll try to use IntelliJ because IntelliJ has very good integration with JUnit. I'm sorry, does that answer your question? Yeah, okay, great. All right. Oh yeah, I'm eternally thankful for our officers. They help me very much. So I'm the president. Ranger here is our vice president. Haijun was online. I don't know if he's still online, but then Michael here is our outreach officer. Trevor took the photo, he just left. He's the program officer. And Isaac was also online, but he also just left. He is our involvement officer, right? So super thankful for these people, right? Last slide. So our website is ufssd.org. Just has a couple links you might want. It has like our, it has the link to our Minecraft server, our LinkedIn, our Instagram. You know, we have an Instagram and a LinkedIn, even though like Discord will remain our primary form of communication, right? Discord, I mean, that's our link, although if you're not on our Discord, I don't know how you're here. So as I mentioned, you know, first half on this Saturday in Franklin at noon. Next week is our Git workshops, both of the Git workshops, right? And so is that my last slide? Yes, that is my last slide. Okay, thank you all so much for coming. I am very excited for this semester. This is, you know, oh yeah, another thing, we'll have elections at the end of the semester. Yeah. So I'm super excited for this next semester. You know, we have a lot of things planned. If you guys ever have any ideas for workshops or, you know, any presentations you want to see, just let me know. Just maybe mention it on Discord, right? Right. Thank you all for coming, and I'll see you guys next week.
And before everyone bails out, because bailing out is never fun, talk with someone before you go, right? So most of the time, like, you guys will stay and chat for like 15 minutes after the meeting. It's generally some fun conversation, whatever else. So I recommend find someone next to you, shake their hand. Don't shake their hand. You know, don't do that either. Right. Find one of the officers and ask, like, hey, how can I do things, right? Like, with product to use or whatever else, right? Figure out a way to get involved, whatever really is the best way to become that developer. All right, enough of me. Done.
Yep. All right. Thank you all online for joining.